Welcome to the InfoQ podcast, a software engineering podcast brought to you by the same team behind InfoQ.com. InfoQ.com is a software engineering news site. The site aims to help progressive software development teams adopt new technologies. InfoQ also brings you QCon, the International Software Conferences. I'm Barry Bird, a professor at Drew University in Madison, New Jersey. And I'm speaking with Courtney Hemphill, a partner and tech lead at Carbon 5. Carbon 5 is an integrated product design and development firm known for its work with early-stage and growth companies. Courtney has done full-stack development for over 10 years for both startup and enterprise companies. Her presentation at QCon New York 2016 is entitled Algorithms for Animation. Courtney, welcome to the InfoQ podcast.
Thank you. Thanks for having me, Barry.
Why should a developer in a large firm or a small startup care about creating animations?
Yeah, it's a good question. I think our interfaces that we interact with in today's software are becoming more and more dynamic. So traditionally, we sort of had this notion of kind of things that you needed a computer to do could be code, it could be a command line interface, and more we're moving towards first the GUI layer, so sort of WIMPs, if you will, the Windows interfaces and icons and pointers. What you see now is we're moving closer and closer to sort of natural user interfaces, and this is something that software engineers across the board need to consider when they're developing programs. So you don't just necessarily have a pointer and a mouse and a keyboard, you actually can squish and stretch things, you use your fingers and your hands. And so animations and the way that we see the reaction on a screen to the types of inputs that we are providing, it needs to feel real. And so that's sort of all based in math and physics in our everyday world. And, the next stage of this really is what people are kind of terming, the natural user interface, but it's also the augmented reality world and the virtual reality world. So we're not there yet, but fundamentally, animations that you see on websites, even on, platform software, it's always been an opportunity for us to have a more fundamental learning about what the program does without needing a lot of instructions or education, because we can intuit, meaning from what we're seeing on the screen and how things move on the screen. And so animation actually functions almost as a way in which for people to discover and explore an interface so that they can interact and engage with it more easily.
How important is it that the animation looks like something that we would encounter in the real world, texture-wise, and so on?
Yeah, it's a great question. If you've ever put on an Oculus Rift and you've experienced judder and you feel immediately sick, that is sort of the most extreme version.
And by judder, you mean?
So judder is when you swing your head around within a virtual reality environment and the screen actually sort of stutters. You're dropping screens in between the animation that's getting painted to your retina.
I know the word jank. Is that the same thing?
Jank is the same thing.
Okay.
And it's probably the more proper word to use. But you can see the same thing on a software. If a computer is running slowly and you see effectively frames dropped, you're sensing something underlying that is not right, and you immediately just trust that thing. So the further away you get from something that is smooth and has the nuances that we recognize as sort of the fundamental physics of reality, you start to have a mistrust of the actual platform, and you start to mistrust, perhaps the data behind it, its ability to be secure and do what you want it to do. So the more you play around with physics in a way that doesn't feel natural, the more fundamentally our psychology will mistrust the actual program.
What about things like natural textures as opposed to cartoon-like textures? Does that make a big difference?
Yeah, there's this argument, and there's sort of a term for it called skeuomorphism, right? How close can you get to natural textures, to more kind of the visual design? We are still working with a digital device, at least now we are. So it's difficult to represent something that has a tactile element to it, whereas actually with animation, we've been throughout the course of history, we watch animations, we watch movies, we're actually okay with seeing a 2D screen representing real world movement, and so we have a lot of experience with it. And even today, if you sort of take that and you translate it to software programs, we used to be menus we would have breadcrumbs, we would have all sorts of ways in which to try to help people to map out what they're supposed to do. And now more and more you're seeing, the cutting edge companies are using animation to help people see where things lie within an interface and sort of be able to proactively map out where the things are that they might need to access in order to get the job done that they're looking to do. So I think that movement is something that is easier to represent in a 2D digital world. Tactile, textures. Fundamentally, Apple tried this. If you remember, they had sort of the calendar that looked like a leather calendar. They had trash cans or something that's often used, right, to give people the notion that you're throwing something away. But trying to get to that skeuomorphous, like tactile, was sort of like the 3D design that Apple used for a while. And you've seen now that most software programs design-wise are kind of moving more to this like 2D flat. Google Material Design really did this, where it's pretty flat. There might be some shading components to recognize depth, but it's really not trying to get to the tactile sense.
So what went wrong with that tactile sense? I read an article whose title was "The End of Skeuomorphism." Mm-hmm. And what happened? Why did that idea not pan out?
It just didn't feel right. I mean, there's no other, there's no research behind it, but fundamentally I think that humans they felt that the thing that they were using was a digital device and should be representative of a 2D digital world. And when you were trying to take something that was attempting a depth to it or a tactile sense, trying to replicate the look and feel of leather within a 2D iPhone screen, it didn't feel right. What you now sort of see has been elevated more is this notion of animation and motion within an interface to really allow people not necessarily to try to represent that actual thing in the real world. You're not trying to present a calendar on a fridge on a screen. That doesn't really feel right, and it's not necessary. But what could be necessary is, how can I navigate, how can I interact, how can I engage with this 2D device and the screen that I'm being presented. It doesn't necessarily have to look exactly like the calendars that were on my fridge growing up. It just has to be able to do the thing I need it to do.
So are there lists and lists and lists of rules for effective navigation with animation in a UI?
I think it's funny because absolutely not.
Okay.
Snapchat, ever played around with that? I mean, it's one of the most popular programs, and if you try to actually find any sort of navigational rule within that program, you will fail miserably. However,
it just works.
It just works, and more than anything, it's playful. Kids pick this thing up, and they will swipe left, right, up, down, all over the place, squish, stretch, and they will discover the things that they need, and they'll have fun doing it. And it's because every action that they take, there's a representative motion animation response from that program that gives them a little bit more information. And so then they just get more and more information from all these different motions and animations, and some of them make no sense, but they don't care. They're going to find patterns within it. So I would say actually there are some rules that people say are best practices, but some people have thrown those completely out and been very successful in doing so.
So what kinds of math will a person be involved in when they're doing animations and creating animations?
Yeah, I think sort of the point of my talk is to try to, bring in some very basic math which lies underneath the layers and layers of abstraction that get...
Is it mostly matrix manipulations and such things?
Exactly, yeah. I mean, transforms, right? Translations, those are what power animations in software. And the basic math around that, fundamentally all that motion is its velocity, acceleration, its interpolation, right? And the interpolation function is really the most simple math that you can get to. What you layer on top of that interpolation function is where things can get really interesting, right? So then you can bring in geometry, trigonometry, and then you get to start layering that more and more, and you get into physics. And then you get into collisions and rules and constraints. And so it absolutely gets very complex very quickly. But for people to understand that really the basis of all of it is just around acceleration, velocity, and the percent changed of whatever, if it's color or motion, whatever that might be, it's really just sort of like where you start, where you end, and then where you're at in the process of that. And then you can manipulate that to n degrees.
But I've noticed now that if I create an animation, and I am not good at it, if I try to create an animation and I say, where do I start and where do I end, and I just put in a linear relationship, start here, end here, it usually looks very bad.
Exactly, right. So we don't live in a linear world. We live in a world that's got torque and yaw and friction and, all sorts of weird physics that act upon motion. And so what physics does and what these physics engines do is they start to allow you to say, this is a world in which I am presenting a actor, a character, whether or not this is something as simple as like a button in an interface, or maybe it's a full screen that's going to scroll past you, or maybe it's a whole game. But within that, you can't just have linear motion. You have to bring in this notion of what are the effects of gravity? How do you bring Newtonian physics into animation? And that's a little bit what the talk is about. And again, the math there isn't super complex, but as you start to layer it upon itself, it can get pretty complicated. So walking through sort of the basis, everything is built upon interpolation, and then how you start to add trigonometry, power functions, sine, cosine, and then above and beyond that, how do you start to consider about constraints, collisions, thinking about things like gravity and forces interacting upon one another. In the talk, I go into sort of the Boyd algorithm, so that is it's the New York version of, if you use it was originally created and it was called the Bird-Oid algorithm.
Spell that for me.
BIRD dash.
I just wanted to make sure. Okay.
Well, the funny thing was when it was named, and it was named Bird-Oid.
Yes.
But then when
and where does that name come from?
I'm trying to remember the guy's name. I'm just blanking right
So
now.
it's the name of a person.
It's the name. No, it is the name of. It was the name given to the algorithm written by a person who was trying to replicate flocking patterns. So you can imagine you see birds in the sky.
I see.
They have this very distinctive pattern. And the funny thing is you can actually replicate that in code, because what's happening there is the birds in the sky are actually, they're interacting with one another, and they're keeping similar yet slightly varying velocities, and all orienting around one center. So the group itself has a center, and that center moves, but they're all sort of swirling around, if you will, this one center. And so you can actually represent that in math. And so that's what this guy did, and he actually named it the Bird-Oid, but then everyone pronounces it with a New York accent, so it's the Boyd algorithm.
Now, I'm going to ask you a question that people ask me about my work, and whenever they ask me, I give them an evasive answer. Let's see how well you do with this.
Oh, boy.
Well, the question is, how long does it take a person to become proficient in such a thing? My evasive answer is always, it depends on you. It depends on what you want to learn. And yet I find myself feeling compelled to ask you this question.
Sure. I would not say that I am an expert by any stretch of the imagination. This is not my area of expertise whatsoever. However, I think the interesting thing for me was when you start learning about animations and the math that is part of animations and the physics engines and what powers them and makes them work, you start to see that it's sort of like, you can find a parallel in this with modern day software development. Everything has a framework. Everything has magic, right? So if you think about sort of something like Ruby on Rails, Rails fundamentally adds a lot of magic to what is underneath it, just Ruby code. So what physics engines do is effectively the same thing. However, if you start at the base, if you start at understanding sort of the core components, and then you layer one by one the nuances on top of it, once you start to get into the really crazy like Unity and Unreal engines, you can have more power to manipulate and understand how to have a greater effect within those physics engines and within those frameworks, because you have that core understanding. So I am not an expert. My recommendation for people is to start at the base so that you have those fundamentals, and then you can start to move into the crazier and crazier realms. And to be honest, you can get pretty far just playing. The frameworks take care of a lot of the math. You don't have to be a mathematician, but you will benefit greatly if you have the foundational knowledge of what it's all built upon.
Would there be any help for a person like me? The math doesn't scare me, but the visual design notion scares me.
Yeah.
So I can't tell when something looks good. I can't tell when something looks terrible. I can tell when something looks terrible, but I don't have any idea how to fix it.
Right.
Do I need to, if I want to put together a cool animation, obviously I would need to hire a designer. But would I be able to do something to help myself out? Or would I be able to do something to help myself communicate with the designer?
That is, again, I actually have given this talk at conferences that are more oriented to front-end design, and my intent is to actually share a common language between development and designers. So at Carbon 5, we have established a practice where the developers and designers do a ton of collaboration with one another. So they sort of pair. So traditional software development, we do pair programming developers sitting next to one another helping to solve a problem. It's amazing what you can do if you sit a designer and a developer next to one another and help come up with an actual solution. Animation houses have been doing this for forever, where you have the animators that come up with crazy ideas and desires for how they want to represent something in their mind on a movie, let's say like a Pixar movie. But for the software to actually support some of those ideas, I mean, literally it's like next generation, decades from now, CPUs that would be required to just be able to generate it, to be able to do the computations alone. However, what they found, and this is what happens at Disney and at Pixar these days, is that those two groups working together oftentimes will actually come up with a better effect for how they can represent this by just that collaboration. And so designers understanding
so it goes back and forth. It's not just the designer says, here's what I want, exactly. And it's up to the coder to understand what it is that they're doing. It's a collaboration.
Right. And the intent of the talk is a little bit to get a shared language. So the first part of the talk is, what do you have to consider around design, and what fundamentally is like the psychology and the basis, the fundamentals, again, of kind of design and animation, and what does it mean to feel right. And the second half of the talk is the math, right? So both groups sort of take from each other, and there's a shared language around design and sort of the principles of design, and then there becomes a shared language around kind of the math and the accessibility of it. So respect on both sides, understanding on both sides, and then shared language on both sides.
So what are some of the mistakes people make when they try to illustrate complicated ideas using animation?
I think, doing too much at once, something that is very difficult for humans to keep track of are really anything more than 4 moving things of note in an interface. And by that, what I mean is that if you have 4 major actors on a screen all moving, that is the maximum that we can handle. So particularly if you're trying to get someone to engage with your program or your platform or your software, you want to make sure that there's enough animation to keep them engaged, but not so much that it confuses them. And there's always a tendency, once you learn something and you get kind of good at it, to just go nuts, right? And so tons of animation, tons of things flying around everywhere. That actually has a net effect of just confusing and losing your end user. So that's probably the biggie, I would say, to kind of watch out for.
One of the biggest things that people did when they first started designing web pages was they added features to their web pages just because they could.
Right.
And the best advice that I heard was, don't do it just because you can, do it because there's a reason for doing it.
Exactly. And the other thing to extend upon that, we have had so much success. You can put something into an interface, you can design it, you can build it, you can do a lot. You have to, at some point, put it in front of an end user, because even if you have measured it and seen the performance be perfect across all the machines, you've done usertesting.com, what have you, you really need to have the person that the program is intended for, so your end user, your real end user, play around, and they are the only ones can really tell you, this is too much, I'm confused, I don't understand where this motion is coming from, what have you.
Well, I can write a paragraph and completely misinterpret it because I wrote it.
Right.
And I'm immersed in it. Is the same true with animations? You can create an animation that looks wonderful to you, says what it has to say, and no one else grooves on it.
Absolutely, yeah. And I mean, it doesn't take that many users to know when you've really missed the mark. It can be, we used to do this thing, we'd do weekly sprints, and we would do user testing at the end of the week. And it would be anywhere from 3 to 5 people, super fast, but you knew really quickly whether you totally missed the mark or whether you were sort of on track. You never know 100%, right? You don't have those quantitative metrics at the end of a week, but you can have that very fundamental, yes, no, we're moving in the right direction, or no, this animation or this design or this interface or the data that we're presenting is just completely confusing.
Are there good and bad ways to impart information? I think most of what we've been talking about is usability. But I'm also thinking about animation as a tool for demonstrating information. Are there tricks to that trade?
Yeah, there's a lot of research that's being done now, and we're actually looking at this also as a company because we do a lot of data visualization for huge amounts of data, figuring out, it's very tricky to represent data within an animated framework. And the reason is that causality for data and the animation behind that is actually really tricky. So you can show things moving in a way, but it actually might confuse people more than their ability to sit down to a static graph or chart or plot and have the opportunity to kind of digest it themselves. So there's actually been research done. Microsoft has a great paper on it about when animation is appropriate for data visualizations and when it's not. So there's no hard and fast rule, but it's if you have something where it's a pretty simplistic rendering and there's maybe a time boundary to it, that's something that performs really well because we sort of see animations happen against time, and so we can understand that. But if there's a lot of different data slices that you need to make, animation can also oftentimes actually make it more confusing. So no hard and fast rule. There are some best practices, but there's some good research going into to how to approach it.
You've mentioned animation in terms of branding.
Yeah.
Can you tell me a little bit about that?
Yeah, so, and this is something that I personally find really interesting. Brands today, they have so many different ways that they can get represented in the world, not just through all the different presentations of them within digital worlds, meaning like, applications, media, advertising, what have you. In order for that brand to really stand up and be known and keep its, really the cohesion around the value statement, it can't just be a simple logo. In many cases, what you see now is that a lot of brands are bringing this notion of design into the products that they create. So first and foremost to this table was Apple. They declaratively really wrote into their iOS framework what the visual motion should look like for Apple products. And so they were able to do that, basically because they were giving the developers the tools to do that exact animation. But now what you see is that Google, with their material design, has done a similar thing. They now have really statements around how you use animation, when you use it, what it should look like, how to test against it. And so more and more companies are doing a similar thing. You've got Facebook has they call it the FIG, I think it's the Human Interface Guideline, but it's Facebook Interface Guideline. So more and more companies are coming out with that. Microsoft has theirs. And it's really for them to sort of fundamentally say, for something that works within this realm that is Microsoft or Apple or Google, it needs to look and feel in this way, and animation actually has a lot of emotion attached to it. If you see something flying across at a Ferrari pace, you're going to have an emotional reaction to that, as opposed to something that very gracefully swoops in. So we actually have a lot of emotion and value that we place on animation, and brands can really use that to leverage to make their brand look better.
So in other words, you can make a statement not only by what your logo looks like, but how your logo moves.
Yeah, and more so how any product that is associated with your company, how the animations interact with that. So, it used to be that designers would come up with the font size, typeface, spacing, colors, yada, yada, yada. You now actually have an additional component, which is anything that is built for a Facebook product or a Apple product or a Google product, it should move with these constraints, with these velocities, with these considerations, within these realms, what have you.
So it should be a consistent experience, not only in the way things look, but in the way things move.
Exactly, yeah.
What tools are better for animation than others? What languages are better to use? Your talk is in the JavaScript track.
Right.
So I assume that you're an advocate of JavaScript for the use of animation?
I'm completely language agnostic. I've used a lot of different ones. I don't think that there is necessarily one language that shines above and beyond. The big physics engines, most of them are written in, some like C. I think Box2D was originally in C#. But it has since been ported over to a variety of different languages, JavaScript being one, so you now have Box2D Web. I think what I would say is it's context dependent. So if you're working in a stack where the front end is, a React or an Angular, and you have an opportunity to use JavaScript, probably the best choice there is going to be JavaScript. However, if you're working obviously in Android or, iOS, you're going to be choosing a different animation framework. So I wouldn't say that there's any one language that really shines above the other for performing animations. If you look at what Pixar is using, then you're jumping into a degree where the language probably matters a lot because the computational power there is just so intense.
So what tips can you give people about performance with animations? I know that animations are processor intensive, so it's problematic. You can drop frames.
Right.
How does one normally begin dealing with that?
Right. So there's a couple best practices. One is I would say one is to test often. So you want to make sure that your frames per second are keeping with it the 60 frames per second or faster realm. That prevents the jank that we were talking about before. I'd say additionally, if we're talking about browser-based animations, which is really what my kind of talk is fundamentally about, you want to consider as much the opportunity to push things to the GPU and off of the CPU. And happily, there's a lot of work that's been done in all the modern day browsers to use CSS to push a lot of it to the GPU. So you can actually do a lot of the painting and compositing within the GPU layer, which is much more performant. So there are some tricks around there to make sure that you're using like request animation frame, that you're using CSS transforms as much as possible. So there's definitely like a whole list of best practices. But at the end of the day, one of the things that you can ensure is rip open your Google Chrome inspector and make sure that you are analyzing, what the heap and garbage collection and, your frames per second and all that stuff. And you can actually, the Chrome inspector is fantastic now. You can dive really deeply in to find exactly where your code is slowing down.
But what about people with different platforms, people with different browsers?
Right.
Test, yes, but how do you test for every possible scenario in every person's office? Yes.
I mean, the honest answer is you can't.
Okay.
Right? So that's why you have customer service. This is for people that do like gaming, right? If you're going to be building on Unity or the Unreal Engine or something along those lines, there's a certain amount of tools that they build in, and I'm kind of speaking outside of my realm when we're talking about Unity and Unreal because I don't do a lot of work with that. But with the gaming world, they have their own set of tools to test and make sure that they're being performant within sort of the software and browser-based world. So, so much stuff is getting pushed to the cloud. You really fundamentally have to do two things. One is what I just said, but secondarily, you have to put things in front of real users. And you can do so face-to-face. You can do so usertesting.com. It is a little bit tricky because it's such an experience, and it is absolutely, some people are going to have hardware that's super old, and it's just going to crash the whole browser. So it's important to make sure that you select to test with some people that are working off older hardware, and you see how your animations are working against that. I would say, though, if you're pushing the envelope with your animations, you're going to probably push yourself to the envelope with people of adopting, faster and faster hardware. And so it's probably not going to run on IE8 or something along those lines. So you kind of have to weigh how much animation you want, how performant you want it to look against who your end users are. And if you're building software for someone that's running on IE8, you probably don't want to be pushing things with, a lot of like crazy animations.
In the old days, web developers had to worry about IE versus Firefox versus Netscape,
right?
For example. To what extent have we solved those problems with things like HTML5 and CSS?
Right. Happily, we're getting better. It's way better. It's so much better. And there's standards are being adopted around each one of these. So there's the Web Animation API, which is the standard that's being adopted by each one of the major browsers, Google, Firefox, and Internet Explorer. And additionally, all of them are doing a lot of work because, people are literally seeing like VR coming down the line and your ability to actually do gaming on the web. So all those browsers are definitely becoming more and more performant around this exact style of thing, animation, gaming, what have you, these like really rich experiences. So I think that we're in a good spot now where you can play around a lot. You can push the types of animations you're doing a lot more than we even like 2 years ago we could.
So while I have you here, I want to ask you about a couple of other hats that you wear. Mm-hmm. One of the things in your bio for the conference is you're convincing people that building less is more and that the cloud is solid and secure.
Yeah.
Tell me about the cloud. Why should I believe that it's solid and secure?
Well, I think what we've seen happen, I've been in development for the last, 10 plus years, and it's tough. You get larger companies today are still pretty reluctant. And I think they're more and more on board with the notion that, they need to be thinking about continuous deployment and the opportunity to push new versions of work that they're doing, not just every day, but really every second, every hour. But there is still convincing as to how valuable that is, because it is to take an enormous company and convince them to get off of this really outdated server software and move to something like the cloud. If they're a hospital, a healthcare company, they have been scared by their legal department and by HIPAA compliance for the last, multiple decades. Scary for them to move to the cloud, right? They have concerns around security and whatnot. And, fundamentally, those are valid concerns, but the tools that we have in place these days really will allow you to move almost any software to the cloud, and you can do it securely, and you can do it faster, and it's going to become more flexible and performant over the long run.
And yet the number of data breaches that we've seen over the last few years, not particularly cloud-based data breaches, but breaches of one sort or another, very impressive ones, has been on the rise.
Absolutely. It's the learning lesson time, right? These are all systems where, in many cases, they sort of are the ones that we get to learn from. So some of these systems were architected not thinking of the potential hacks that were going to be coming up, right? We're always going to have to respond to attacks, right? There's always going to be a backdoor somewhere, right? You can't lock every single door, particularly in systems that are super complex. But what you can do is start to think more and more about where are all the most important pieces of the data that need to be super secure, and focus in on that first and foremost and pay attention there. There's amazing opportunities moving forward with things like the blockchain and PGP, where, fundamentally the cloud isn't the problem, right? The cloud isn't the culprit. You could, there's security track here where people are talking about, how easy it is to really get at almost any data. And even cloud-based or not, you can call up a customer service rep and you can get access to people's credit cards and whatnot. And so in any case, long story short, I fundamentally believe that the cloud is the opportunity for us to be able to respond more quickly and more proactively to any sort of opportunity as well as threat. So that is why I believe in the cloud, if you will. And I also think that the cloud is our opportunity to move forward more quickly than you can if you have these systems that, just sit in someone's server room and you really can't push new software, new opportunities to those servers because they are contained.
Okay, and I'm also going to ask you now about another point on your bio. You mentioned women who code. This is somewhat a selfish question on my part. I work at a university where we always are struggling with the notion of recruiting more women into the program, in the computer science program. Can you help? What can you tell me about that?
Well, the irony is that it used to be flipped. It used to have more women coming out of computer science programs.
That was a long time ago.
It was a very long time ago, but it fundamentally, all of these programs, all of these efforts are slowly and progressively moving us towards that again. It's the most frustrating thing for me right now is that, we suffer because there was this time period where women effectively left the sciences, and we started to see, in pop culture, in media, a representation of geeks or people that were computer savvy as being men. And it, you even go back to like the 1980s film Nerds, it's like those were all a bunch of dudes mostly. So, I feel like what we need more and more is an opportunity to showcase, based on example, all the amazing computer scientists out there that are of a very diverse background, ethnicity, sex, whatever, and to have those people help to level up all of these people that are now actually going into boot camps. They're becoming interested in programming. They see sort of the benefits and the interesting work that they can do within that world. So it's sort of this pipeline effect. The tricky thing is you can't have senior women falling off because they have to sort of help to level up and provide an example for people that are coming up. So I'd say, it's sort of a double-edged sword, but keeping senior women in the workforce is really important, making them visible and allowing access to them so that they can inspire and be shown as an example to other women that are coming up through the pipeline. and to help them find resources to level up all of the women that are coming out of the boot camps and providing them the resources. I love Women Who Code is one. Railsbridge is a fantastic one. It's free weekends full of coding
for Ruby on Rails.
Ruby on Rails specifically, but we also have an Android track. We have a JavaScript track. There's a Java track. And these are people dedicating their weekends and their time to just teaching people to code, women to code. So
fantastic.
Yeah.
Let's get back to the subject of animation. What are some of the current trends in the development of good animations?
Yeah, it's funny. Most of them are subtle. I think one of the ones that I love the most is that you used to constantly see, we have the most bloated internet ever. Most pages that you load now are like a million megs, 1 megabyte or 100 megabytes at a minimum. So like New York Times, right? Like you download that thing. It's
larger than my first hard drive.
Yeah, and larger than War and Peace, right? Yeah. You shouldn't have one web page that is, telling you some simplistic thing be bigger than a volume of Russian literature. However, what I would say is there's this opportunity to use animation, and I've seen people do this. Instead of having like a spinning loader where people are sort of just waiting there drumming their fingers, you can kind of show them what's to come. So I have seen this sort of like staged animation of a page, and sort of the actual content isn't there, the image isn't there, the text isn't there, but you're seeing the basic layout, if you will, of what is to come. And they sort of stage it, right? So you get the first box, and then you get like the 2 different boxes that represent the text. And so you see this on Facebook, you see this on Google a lot. But it's a neat animation that sort of keeps people engaged. So animations that I think are valuable right now are honestly ones that keep people engaged with the product that you are building, and keep them coming back, and also help them to understand where things lie. So, when you've got navigation, particularly this happens all the time on the iPhone, and these aren't just apps, you can do these with like websites, where stuff has an opportunity to slide in from the left, the top, the bottom, wherever, and you can kind of map out easily based on where things are sliding and going, how to access different elements of an interface. So I like those two.
Are there any far-reaching future goals for desktop and browser-based computer animators?
I'm sure there are. I don't think I'm at the forefront of the industry, so I can't really speak to that. But I'm seeing we have been playing around a ton with augmented reality and VR, and that is fundamentally now a browser-based opportunity. So, A-Frame is this new framework that came out, and it's basically just web components that build up this virtual reality platform. So you can create games super easily.
How is it a browser-based opportunity?
Well, because you can do, with Google Cardboard and, with the Chrome nightly builds, you can actually have a web page that you load up onto an Android or an iPhone. You can plop it into Gear VR or Google Cardboard, and you can actually create a web page that represents a virtual reality. You can do it with, a photosphere, just dead simple. You can create a game. You can even do, you can actually visualize data in 3D. So super fun stuff that you can do. And literally it takes, an hour to build, deploy it onto Heroku, and then shove it into a Gear VR and look at it. So it's pretty fun.
Sounds really exciting.
Yeah.
You've been listening to the InfoQ podcast. I'm Barry Bird, and I've been speaking with Courtney Hemphill, a partner and tech lead at Carbon 5. Courtney, thank you so much for being here.
Thanks for having me.